Hello everyone, just checking if you can hear me and see me okay. Just put a thumbs up in the chat or say hello. Great, thank you. Before we get started with this webinar, I'd just like to ask everyone to turn off their notification settings. If you haven't been to one of these webinars before, sometimes you get the pop-ups and the sounds during the session, so just please make sure you go to your notification settings and untick all the boxes there, and that will prevent any of those pop-ups or sounds while you're trying to watch the webinar. So I hope you're all well. My name is Riley and I'll be your host for this technical webinar today. The topic is Renewable Energy-Based Distributed Generation System, and the presenter is Dr. Munira Batul, who is a lecturer and unit coordinator at EIT. So just some frequently asked questions. Everyone registered for this webinar, and in this session we'll receive a copy of the PDF slides and a link to the video recording within the next 2 business days via email. And please monitor your junk email folder for that one. We also provide a free digital certificate of attendance for these technical webinars. I will provide a link at the end of this session, which will take you to a short form survey you must fill out in order to receive one. So just a brief overview of EIT if you're new to us. We are one of the only institutes in the world specializing in engineering. We have a range of courses with course types from short courses to diplomas and advanced diplomas. And in the higher education space, we have undergraduate and graduate certificates, bachelor's and master's degrees, and a Doctor of Engineering. Now we have industry-oriented programs, so all of our courses are regularly updated to stay relevant with changing technology and industry developments. Our vocational programs and higher education degrees are registered and accredited by the Australian government. We have programs that are also recognised internationally under one of the 3 international engineering accords, the Sydney, the Dublin, the Washington Accord. We recently just had an update on our internationally accredited courses as well, so we have even more now that are internationally recognised that you can look at on our website. We have industry experienced lecturers, so all of our lecturers have a high level of experience in the industry and in teaching, and we source our lecturers from a large pool of expertise, so all around the world. We have a unique delivery model, so that includes live and interactive webinars similar to the one you're in today. However, we stick to small class sizes, so if you're a student at EIT, our webinars would be a lot smaller than this, and you'd be interacting with your peers and your lecturer more hands-on. We have dedicated learning support for our students, so right from when you start an EIT program to when you graduate, you always have someone to reach out to if you have any concerns with accessing the course or with the content. And we also have state-of-the-art technologies such as hands-on workshops, remote laboratories, and simulation software. I'll hand over now to Dr. Munira Batul, who will be presenting this technical webinar for you today. Thank you, Munira.
Thank you so much, Riley, for the introduction you have presented. Hi, everyone. I am Dr. Munira Batul, and currently I'm working as an online lecturer and unit coordinator, and as well as postgraduate research supervisor with EIT. I had done my PhD in electrical power engineering from Curtin University of Technology back in 2019. So currently I am working on the research which is based on renewable energy sector and modern power systems as well, like smart grids, microgrids, discussing about their power system analysis, about their power quality side. So we will be discussing in today's webinar the basics and some research perspective on renewable energy today. So these are the highlights of today's session. Introduction has already been presented by Raleigh, and I will be focusing on three basics areas today. What is actually a renewable energy technology and how it is being implemented with the example of Australia as a country. We will see that how renewable energy is progressing within Australia, although it's progressing all around the world as well. Then we talk about distributed generation, why it's important, and what are the core key features related to distributed generation. And at the end, I will be discussing one of my own research project, which recently has finished on this topic. And finally, we will be having our question and answer session with the conclusion. So let's start with our domain one for discussion today, that is related to renewable energy technologies. So as we can see, all around the world now we are facing the problems of global warming and environmental pollution, and because of that problems, it's needed that we promote more and more integration of renewable energy resources. There are several reasons behind that. We can see that all around the world, we are also facing a crisis in the fossil fuel supplies like coal, oil, natural gas. These natural resources are declining. Then the cost of the fuel, of course, all around the world, the costs are day by day, they are increasing. So we need to switch to some way which can provide us less costly way of production of electricity. And then also, of course, we have some political concerns which are related to, because we don't want that global warming to go to very high level. And of course, environmental concern, I think the major reason why we are promoting the progress of renewable energy sector is the environmental issues. We can see all around the world the weather has been changed a lot. So winters are squeezing, summers are extending, and natural disasters, unfortunately, are also occurring. So that's why environmental concerns, I think, is the major focus why we are promoting these renewable energy in our power system side. So being an electrical engineer, for myself, talking about this renewable energy perspective is not only the technical one, but also it's because of the health and environment perspective of uh, our nation internationally. We are promoting this one, and a lot of work is going on the research side in other technologies of engineering as well in this sector. So if we look overall, what are the renewable energy technologies and how we are working with them? So there are several implementations which we can see in renewable energy sector. Like we have we have biomass based renewable energy, which is based on like the production of electricity from maybe the agriculture waste or maybe the other waste materials. Geothermal is related to utilizing the energy which is present beneath the surface of Earth. Hydro is related with the production of electricity from kinetic energy of water, and hydel is basically not a new one. It's a conventional one, but of course it's a clean way of production of electricity. And solar and wind, these two are in more common use nowadays, and we will be focusing on discussion on these two as well in our discussion today from the research perspective, which we have just finished with some conclusions that if we integrate these two resources, then we can get a good amount of electricity with accommodation of load in a good way. So let's have a look on Australian initiatives which has been done so far for renewable energy sector. So if we go in past, we can see that Australia has started promoting renewable energy sector more than two decades before, and we can see it started from like in end of 1995, and then still now there has been a remarkable increase in the renewable energy sector, in which lots of other renewable energy technologies has also been introduced. So you can see from here, it's a rough graphical depiction of what we are having right now in Australia. So hydel is also there. Wind contribution and solar contribution are also there because of the weather conditions over here. We have a lot of amount of sun energy which is available. Coastal areas are here, where through which wind production, the electricity production through wind, we can say, is very easy. And bioenergy is also now being focused because of a lot of agriculture wastes which are there, and agriculture sector which is very common in Australia. So that's why bioenergy is also now being promoted over here. So as a rough sketch, renewable energy resource accounted for 8% of Australian energy consumption as per the records which has been taken in 2021. So coming to some examples of renewable energy agencies which are working in Australia currently, one of the famous one from the Australian government is ARENA, or Australian Renewable Energy Agency. The mission statement for ARENA is that they support advances in renewable energy technologies, and they are also promoting the innovation which is happening in renewable energy sector. The innovation is not on the practical side only, or not only on the giving the like electricity which is going to the load centers directly, but it starts from early stages in the labs. There are research labs which are working, and then they demonstrate the projects, they demonstrate the feasibility reports, that how much feasibility is there for the production of renewable energy, and then it goes to implementation side. So as per statistics of ARENA, it started in back in 2012. So as per statistics, now currently 632 projects are working with 1.96 billion investment, which has been done so far in renewable energy sector related projects. So there is a sub division which is working under ARENA, which is devoted for distributed energy integration program, and shortly it's known as DEIP. So the distributed energy integration program is totally focused on looking the promotion of renewable energy integration at different sectors and at different levels, like government agencies are working in cooperation with market authorities, industrial and customer associations are also there, private sector is also involved, in which we have the process of deregulation, and we are having exchanging information where this particular region is under ARENA. They are collaborating with the distributed energy related issues which are very common nowadays, like we are having power quality issues which are going on because of integration of renewable energy. We will be also talking about them as well in our today's session. So these are lots of flavors which are related to renewable energy, which has been is investigated, and then some of the research and then development has been taken place under this program. Another very famous Australian government based sector is Clean Energy Finance Corporation. So Clean Energy Finance Corporation, the main aim and mission of this corporation is to promote, of course, renewable energy sector sector so that we can have the ways of production of electricity through clean energy. They have set their target until 2050, and 2050 they will be having this perspective that they are committed to accelerate the transition to net zero emissions. So basically, they are looking for all of that sectors which are not including harmful emissions, which are very dangerous for our environment. For example, coal thermal power plants. We can see that coal-fired power plants, which were common and still they are common, we are producing electricity from that thermal power generation based on fossil fuel of coal, and that coal is emitting some like carbon dioxide, and then we are having nitrogen related oxides which are very harmful. Even the mercury emission in some traces amount are also there, which are very harmful, of course. So that's why the mission of this corporation is to take Australia to net zero emission by 2050. So some more statistics we can see, which has been produced by Australian Energy Mix by with the perspective of state and territory. So overall, if we have a look at the fossil fuels, like fossil fuel is this cap, coal, oil, gas, and then renewable is this one. So overall, if we look at the trend, then we can see that all of the states, they are now have shifted to renewable integration, and more integration is being focused in Tasmania. So we can see overall that Australia as a country is promoting, not only Australia, but of course all around the world, the countries are now focusing on renewable energy integration. These are some more percentages which we can see. Of course, as COVID has affected all around the world, so it also has affected renewable energy sector. So we can see 2.9% decline can be seen in energy consumption by with the period of COVID, and 7% of solar now consumption is there. Overall, if we look at renewable energy sector, 15% is there from wind generation. And overall, if we look towards that climatic changes which are happen over here in Australia, it's 75% chances are there that this temperature keeps on increasing. So is a lot of need that we need to look to energy sector. We focus on more, and these statistics are showing us that Australia 2021 statistics that every state has been promoting more clean energy and renewable energy sector, and they are investing more and more finances in renewable energy sector as well. So these are one of the example which I have included over here from the perspective of South Australia. So Australian energy market operator, they have investigated this thing that if we look towards total production side from South Australia, and how they are producing their electricity. So 35.7% is from gas-based resources, 43.9% is from wind. So it's a lots of contribution what they are having. Rooftop solar and utility scale solar are also being in use and covering 14.9%, while 4.6 are utility solar and 14.9% are rooftop, and 0.7% are battery storage, which is actually giving a support to this system. So overall, we can see that renewable energy demands, they are increasing. If we even take the data for 1 year, then we can see that with the passage of time, it has increased. So customers, consumers, they are also being interested in using renewable energy as the source of electricity generation, and also utilities are promoting the more investment in renewable energy sector related projects. So these are some of the totals, but we can conclude according to states that how many investments are there from every state in Australia in renewable energy projects. And of course, being for electrical engineers, for technicians, for the people who are working in renewable energy sector, there are a lot of jobs which has been created as well with the promotion of this renewable energy sector. So, as I mentioned earlier, that I will be discussing one of the case study which will be related with the renewable energy sector. So, the case study will be focusing on wind and solar. So, let's have a short look for wind energy, that what it is and what are our we are expecting from this sector, that what it can produce and how much energy it can give us. So wind energy, with the passage of time, it has got more mature. And if we look towards the past few 10 years, then this sector has been promoted a lot. It can come in many sizes. It's not only important that we can use it at small scale, but now large scale wind farms are also being utilized as producing the generation mix on generation side. So cost competitiveness is there in this sector, because of course implementation from wind energy sector, its installation takes a lot of money. So installation is costly, but of course once it has been installed, then we can expect that we can get long time benefits from this wind energy. Large wind development has, of course, clear impacts on neighboring communities. They actually are also promoting the stakeholder engagements in that one. So if we look on project types which we can promote related to wind energy side, then one of the idea for project related to wind energy can be remote power. It can work with remote communities. Remote communities mean that if you are having some consumers which are there in remote areas or remote towns, particularly in Australia, we are having a lot of examples that in Western Australia, for example, it's a very large state, and there are a lot of remote towns are there. And for that remote towns, if we are only focused on conventional ways of electricity production, then we have to apply long length transmission lines. And long length transmission lines, of course, cost is involved, and losses can also take place. So that's why, in order to facilitate these remote town areas, it's a very good idea that if we can utilize their natural resources, because they have abundant of amount of solar energy, and these are also including coastal areas. So that's why coastal areas can also produce a lot of wind energy for us. And another project idea which we can take is on-site energy production and consumption. And that on-site energy production and consumption can be done with the integration of wind energy along with our utility services, and we can facilitate our residential, commercial, and industrial sector as well. So at industrial sector, of course, because heavy loadings are there, so that's why we are much more interested to facilitate this industrial sector to manage their heavy loads. And energy for sale can also be available, because we know that deregulation process is all around the world now. So we can have small businesses, small companies which are working in this sector. Our utilities can purchase power. They can go into mutual collaborative contracts, and then they can sell and purchase power from that companies. So this is one of the idea which we can get from Australians wind energy projects. So as the statistics relates, Queensland has currently 14 projects ongoing with 56 billion investment in wind energy. New South Wales is having 17 projects with 13 billion, Victoria 13 projects with 6 billion, And South Australia is having currently 8 projects with 5 billion of investment. So like we can see, depending upon the weather circumstances, because wind energy is totally associated with that what kind of wind energy you are getting on site location. So that's why these states are having more feasibility for implementation of these wind energy projects, and we can see that they are investing a lot for successful implementation of these wind energy projects. Solar energy, a very common one. I think not only electrical engineers, but other people also have clear idea now about solar energy, because we are user at some point in our lives of solar energy nowadays. So solar is basically the basic definition is using the solar and the sun energy for production of electricity. We utilize solar modules. We are having a much more sophistication which is coming in this sector with the passage of time. So alternating current PV systems with inverter implementation is required for its implementation. But there is another thing that we need to think, first of all, at which level we are going to implement this solar energy, whether it's like a small scale level, maybe on the distribution side, or in your houses you are producing, you are going to facilitate your commercial sector or industrial sector. So battery storage system is necessary to be implemented along with solar if we want to store energy, if we are having excess power generation from solar. So what we can do at the night time, so of course sun is not available, so that's why we can consume that stored energy at the night time, which has been stored in our battery once night time is there and no sun is available to us. So there are different solar technologies. As I mentioned, that a lot of sophistication and improvement has been done in this sector, because it's a very common all around the world. And people and governments, they are investing more and more in solar. So we can find out photovoltaic, like simple PV modules which are working. We are also having concentrated solar power. You can see the designs actually gets changed, and there are systems which are having sun seat onto a generator to produce electricity directly. Solar heating can be there, like we are having the solar collectors which are absorbing sun energy to provide low temperature space or water heating. So its only purpose is for small scale implementation of water heating. Solar lighting also can be there, like we are having some infrastructure which actually can work out with natural interior lighting or piping lighting indoors using the fiber optics as well. So there are energy conversion, and there can be conversion types which are being associated with that, because initially what energy which we produce from solar is DC, and we know that our power systems, they are working with the AC. So that's why we are having more loads which are AC. So in order to facilitate that loads with this solar, we need to convert DC to AC energy, and energy conversion is required. So this is a rough estimate what Australia is forecasting for solar capacity by 2030. So by 2030, Australia is expecting to have implementation of solar capacity goes to 80.2 gigawatt. Until now, by statistics of 2022, they are having 29.3. So this is the forecasted amount what we are expecting to happen in Australia in different sectors of residential, commercial, and industrial as well. So this is a simple graphical description which I have included over here to give you idea that how the rooftop solar implementation has got increased with the passage of time. So you can see that by 2010, people were not that much interested in rooftop solar. Might be there were like some things were there in their mind that we will not be getting proper electricity, or the billings amount may be increased. So there were several concerns, of course. But with the passage of time, you can see we have got until here, like it has increased a lot by the year of 2021. So rooftop solars even has got increased as per the report which is being published by ABC Ruler. And this is actually the utility solar, wind, and battery capacity and their construction, which are associated with the passage of time. So you can see that every year, in fact, in 2018, a lot of construction in solar, wind, and then battery associated, in which lithium ion batteries are involved, they are being promoted. But there is another thing which has been included, which is based on that why not we utilize large scale wind farm. And in the year 2022, the new thing is that now the research and implementation is ongoing on large scale side. Instead of having like small scale side, now government bodies and research is promoting the investments and implementation of more large scale farms, wind farms and solar farms as well. Now, this was our domain one of discussion. Now, domain two of discussion, let's start with the domain two of its discussion that is related with distributed generation. Now, if we look on distributed generation concept, now being electrical engineer, we take it as the dispersed generation. Like if we look at hydel or thermal power generation side, they are concentrated one. Like if you are having a generating station, it will be only located in that region in where the resource is available. However, this distributed generation, it's not like that. It can be a generation mix on your generation side along with conventional one, but you can also have integration of renewable energy at different points in your power system. It can, for example, rooftop solar system, it's a beautiful example of this distributed generation. So you can see that you are integrating solar at your houses. You are basically your house can be a nanogrid. You are having a solar rooftop solar PV system on the rooftop of your house, and you are managing your loads with that. There can be different possibilities. Then they can come like you are having collaboration with your, or you are having in a contract with your utility or not. So that depends upon that what kind of generation mix you are using. Overall distributed generation concept is refers to power generation at the point of consumption as well. So now the previous concepts that only the electricity can be generated from the generation centers is no more there. We are having renewable energy which is there available at distribution sites as well. So that's why we are significantly increasing the penetration level from renewable energy resources, and it requires a revision of the way of power system and are designed to operate in order to better accommodate these sources as well. So this is a rough sketch what we can expect from renewable energy resources integration and interconnection in form of distributed generation. We can expect if we are having a central conventional generation system, then we can integrate large scale wind farms, large scale solar, geothermal, hydro, transmission levels can also be facilitated with that. So we can make a generation mix. So this idea actually exists at central station in which you are going to mix the energy with conventional power systems and renewable energy resources. Now, the second idea for distributed is that you can have small wind, solar, fuel cells which can be interconnected at distribution level. So you can see this one is generation level. As for power system, we have three levels. Like the first one is generation of electricity, the second one is transmission of electricity, and the third one is distribution. So at generation, we can have generation mix. Then at distribution level, we can have this integration of renewable energy at different points. And it can be facilitated with different renewable energy resources. The more common are solar and then small scale wind, which are in common use nowadays. Now, once we come to DG system integration, it's not a simple task like as we are discussing over here that we can integrate distributed generation and renewable energy resources. There are a lot of thinkings and a lot of perspectives we need to consider. For integration of distributed generation system, we need to look at whether we are meeting the criteria for technical codes and standards or not. For example, we have IEEE standards, we have IEC standards, we have your international and national standards as well. For example, in Australia, we have Australian national standards as well. So we need to look that if you are planning to integrate renewable energy at different point in your power system, then whether the produced electricity is going to meet technical codes or standards or not. If they are not meeting, of course, you will be having more losses. You will be having bad power quality in your system. Then the implementation of advanced technology is also needed. It's not only the thing that you have solar and wind like integrated in your system. Along with that, there are a lot of things, technical things which are being involved. For example, for solar, you need to have proper converters which are working for you. For wind farm, you need to have proper like doubly fed induction generator, permanent magnet synchronous generator, like these generators needs to work for wind energy, because wind energy and solar energy, they are good to be implemented. But as a renewable energy sector researcher, I always used to say that renewable energy is good to be implemented, but there are lot of technical challenges which we have. It's not easy actually to implement, because when it comes to technical side, then there are lots of challenges in terms of maintaining a good voltage, good current at consumer side. So if we are not able to facilitate the loads accurately, then of course we will not be able to maintain a good power system. So rules, policy, procedures, and agreements should be there. Now, it happens, and it is basically, it can vary from government to government, it can vary from country to country, that what kind of rules, policies, and procedures they have there for renewable energy integration. So before distributed generation system integration, we need to look on all of these factors. So this is basically, these two are related to technical side, and this one is the administrative side. So now coming to stakeholders, actually the participating entities which are working with distributed generators. So distributed generation not only is all about that we are integrating solar or wind, it is actually depending upon that what will be the cost, environmental impacts, and reliability on the side of system owner. So if you have integrated solar rooftop PV system, then you need to look on these challenges. Then system integrators, how good actually you can integrate this system. For example, like on the installation side, or if you are having a business plan, being a small scale renewable energy investor, then you need to look that where the economics will go, whether you are getting the good response in terms of power quality from your system by integration of solar and PV or other renewable energy resource or not. You need to follow regulations and all of the rules which are being settled by or set up by your governments. there are authorities which are having some rules and procedures we need to look, like there are utilities which are usually government owned. They define the procedures and they define laws which we need to follow. And of course, we need to be in line and in communication with our utility. So these are best practices, what we hope for DG interconnection. Like if we are planning to have distributed generation, we can give our customers with the benefit of good electricity by following these are all best practices. Like the proper guidelines should be there. We need to have paths of impact study, low cost, of course. The concern from the consumer side is to have a good incentive in terms of cost. Uniform state rules for utilities, we need to follow the standards. We need to have screening option. Screening option means that whether the capacity which we are hoping to be there to facilitate our load is there or not. And a modeling platform is being followed. You are keeping up good communication with your users or not. There are online tracking system, like we are having web portals and mobile apps which are giving our customers the access to their accounts, so they are not only paying for what they are getting, but they actually can see what they have consumed and what they are paying for. And standard impact studies are there, cost effectiveness and mitigation strategies that is related to power quality side. And of course, we need to look towards some moral values of attitude between utilities and developers. They are in on good terms or not. And regulatory organizations, they are happy with integration of distributed generation system or not. So now there are some keys to successful projects in distributed generation, like quantified. If we have properly sized renewable energy resources and we are implementing them, if we have properly investigated the path and timeline for their implementation, developers are there which are working throughout with the technologies which are coming up, documentation is properly done in the past and in upcoming future, and the solid business plan should be there. So it means that we need to first of all have planning and development properly. Then we need to go to implementation side. Planning and development, of course, transmission system planning, how it is there, and then integration planning, it is very important in renewable energy sector. So these are some quantified renewable energy resources, how they can work, which is our focus today for discussion, that renewable energy resources needs to go through primary screening. Primary screening mean we need to look at whether the environment at specific location is favorable to implement renewable energy resources or not. We need to do the final screening for them, that whatever the capacity what we have proposed for a certain implementation, it's in line and it will be good to implement. And feasibility study is very important. Like as I have mentioned earlier in earlier slides, that feasibility through the rules, regulations, and implementation is very important. And then we need to go to sizing and design of renewable energy resources. Now, let's switch to discussion domain 3 for today. And I have now in discussion domain 1 and 2, I have explained you renewable energy sector with an example of Australia. And then we had discussed domain 2, which was based on distributed generation. What are technical and administrative things which we need to discuss from the perspective of distributed generation? Now I am going to show you some of the research study which we have recently finished. And these are the details about the project. So the project title was Performance Analysis of Renewable Energy-Based Distributed Generation System. And we had utilized artificial neural network with implementation, which is implemented on Unified Power Quality Conditioner. I supervised this project I myself was the supervisor, and I'm thankful to my the team which has worked for day and night with me to make this project successful, and we were able to get results out of this study in October 22, when we had published the findings of this research, and they got recognized by the platform of IEEE Access. So I have given a source link over here. By clicking on this reference, you can straight away go to this publication. So you can find out more detail about this publication over there. So over here, looking at the time, I will be explaining you that what we have done in this project, and how it is linked with our renewable energy sector. So let's start by looking at some of the key ideas what we have proposed in this project. So the basic proposal of this project was to check that if we are integrating solar and wind combinedly, so it's a mixed generation from solar and PV, we have actually implemented it on low voltage distribution network. Then after this implementation, we have analyzed that there were lots of power quality issue. Now, before going further, let me explain you what are power quality issues. So if you are getting voltage distortions, if you are getting harmonic problems, current distortions are there, or flickerings are there, which are visible from your load operation, then it means that power quality which is coming from your resource is not good. Then you need to take certain measures. So we have implemented it on a distribution network. It was a practical one. So we have noticed that there were lots of harmonics and voltage disturbances were there when we checked the system. So we had proposed that why not we implement unified power quality conditioner. So unified power quality conditioner, actually one of the research paper was published on this one, that how unified power quality conditioner can work best. But then we noticed that the amount of harmonics and voltage distortion, they were not they were not a very good one. So we have proposed another technology over here, that why not we implement some control over this. So we proposed ANN control. And then in the next step of this, we wanted to look that the power quality conditioning, what we have seen in this network, either it was good with ANN. So we have also compare it with another controller of PI. So the core objective actually of this research was to check the performance of the system, which is having integration of wind and solar with implementation of ANN-based control on UPQC. So UPQC, basically, what is UPQC? Unified Power Quality Conditioner. It's basically a controller which gives us very good conditioning and power system analysis of all the network. And with the help of this controller, we will also be able to control power quality sector and power quality parameters of some system. So we have actually the objectives what we have achieved from this system. They were that we implemented successfully this ANN-based controller with UPQC. We improved power quality issues on the system with the implementation of solar plus wind, and along with converters. We injected the power by a photovoltaic system. We compared the performance by different controllers, like in this case, ANN and proportional integral controller was investigated and compared. And we then checked the results according to IEEE 519. IEEE 519 is a standard which is explained from IEEE, and based on harmonic distortion, both voltage harmonic distortion and current harmonic distortion. So successfully, we have achieved our system harmonics, which were coming within the limits which are defined by IEEE standard. So this was the simplified block diagram, what we have used for our renewable energy based UPQC-ANN system. So this is the name of the system, what we have done. So basic idea was that we were working with the grid. This was point of common coupling 1. And we were having integration of solar and PV over here on the DC link in order to actually control the performance of the inverters which are working with the wind and solar over here. We have implemented artificial neural network based control. We have then facilitated our system with filters. Now the purpose of filters over here, of course, is to mitigate that harmonic issues. And then after this we have implemented and checked it with the working of non-linear load over here. So this was the schematic diagram what we have developed, and this project was carried out on MATLAB Simulink. So you can see, of course, it's a complex circuit. So you can find out details, as I said, in a research paper, but just giving you a short idea that what it is. So basically, this was a three-phase system. So this was power supply, and then we had defined this point of common coupling 1 to check and analyze our power quality. Then we have implemented, you can see over here that wind is coming. And along with the wind, we had utilized the permanent magnet synchronous generator. On PV array, we also have implemented these inverters. So successfully over here, when we go to load side after implementation of these inverters, the purpose of inverters is, of course, to convert that DC input which is coming from PV and wind to AC. And then we can go to point of common coupling 2 for analysis purpose. So basically these two critical points are there to look at that what is the status of power quality parameters in our system. And then we will be able to accommodate the loads. So these were conditions which were implemented on UPQC system. There were 4 operating conditions. Now, these 4 operating conditions, how they were different from one another. The one difference what we have created is the difference in source and load voltage. And the second difference what we have created was checking up that what is the power coming from our renewable energy resources and what is the ongoing demand from our load side. So this was a whole structure of working of our system. You can see that this table is enlisting all of the component ratings what we have utilized for inverters, for solar, for our photovoltaic system, for wind and nonlinear loads. And this is the flow chart of performance. So you can see that once we create the scenario, then we need to check against 4 operating conditions, that whether any of the scenario or any of the any of particular ongoing situation, it meets up with this out of these 4 scenarios or not. So these were the operating condition technical data. So we have this table is enlisting that what was the grid voltages in all 4 conditions for PI controller first and then for ANN controller. Load voltages, load side voltages against every operating condition, grid currents and load currents. And these were the harmonics which are being noticed for every operating condition against every grid voltage, total harmonic distortion concept. So total harmonic distortion or THD concept, a very common one which we use on power quality side. So basically this concept relates to investigation of harmonics and looking towards the distortion and looking for possible ways to bring down this distortion. So then load voltage, grid voltage, load currents, these are all the harmonics which we have got. I will be showing you the graphical depiction in the coming slides, and then you will get idea about this technical data more clearly. And then you can see that these were the power factors. Now, power factor, why it was important? It's power factor is also a key component in power quality. So if we can be able to check the power factor, that whether it's within 0 to 1, or whether it's going to be near to 1, then it will be a good one. So we have noticed different operating conditions. So these were the operating conditions. In the first one, we have investigated that no power is coming from PV and wind. Like you can see, these are zero powers, and we are only receiving power from the grid side. So we can see that a lot of distortions were there. In operating condition 2, we have now brought up our PV and wind power to approximately 3500 watt. And then we have noticed that what is the situation on the load side. And then we have noticed that what is the situation, what we are having on the three-phase voltages, on the grid voltage and current, and the load voltage side. And this is the operation condition 3, in which we have uh, applied the active filtering condition. So you can see now a clear difference can be seen in harmonics. These harmonics got reduced with the implementation of filters. And this operating condition 4, it's now we have incorporated our artificial neural network controller, and we have now investigated that the quality of power in voltage and current waveforms got much, much better. So this is a comparison what we have got for this study, that in all operating conditions, when we compare the average total harmonic distortion of load voltage for ANN, it's much reduced as compared to PI controller. Similarly, for current distortion, we can see ANN topology is much good and reduce the harmonics more as compared to PI controller. So we can conclude this research over here. The conclusions what we have found from this research study was that it's good to implement renewable energy resources at low voltage distribution network, but it's not, of course, a task which we can do randomly. We need to propose proper controller which can actually help us to control power quality conditions. We need to have a top-up controller which can actually refine the total harmonic distortion, current and voltage distortion limits. And this simulation results, what we have got from this study, they actually have shown us that with UPQC, we can get results which will be within the IEEE standard. But with the top-up control of ANN, we can get more refined power quality limits, and our loads can be operated in a very smooth way with the implementation of this UPQC with the ANN-based control. So we, in this research, the comparison was conducted between different case scenarios, and all of the case scenarios, the conclusions were that we can integrate DGs at the point of common coupling at low voltage distribution networks. But if we can make some arrangements for power quality conditioning, then it will be a good idea to control the power quality limits of the system. And it's very important, because if we will not be able to control power quality limits, then of course we will not be having a good system which can help us to facilitate our load smoothly. So this was all about today's discussion, everyone, from my side. This discussion was based on renewable energy sector, which is having distributed generation integration. And I hope you have got a short idea that what is renewable energy, what is distributed generation, and how in research we are now utilizing this one. And of course, after the research, the implementation stage is also working for us. Thank you so much. And it's all from my side. Now I hand over to Riley for the next few more discussion.
Thank you so much, Dr. Manira. That was a very insightful presentation. Before we wrap up today, I'd just like to go over some upcoming programs in our electrical engineering school. So you can see there we've got a professional certificate of competency, which is a name for our short courses. We have a hydrogen energy short course coming up on the 24th of January. We have electrical power system fundamentals for non-electrical engineers on the 13th of February. We also have our bachelor's in electrical engineering, as well as our undergraduate certificate on the 13th of February. And we also have a short course in electrical power system protection on the 20th of February. And if you're looking to study on campus in Australia, we have our bachelor's, master's and doctorate degrees starting on the 20th of February. And finally, our popular Advanced Diploma of Applied Electrical Engineering and Electrical Systems is starting on the 3rd of April. I would recommend going to our course schedule page on our website to have a look at all of our upcoming courses and intakes. And these are our upcoming webinars as well, if you would like to register for those. We have one next week on introduction to electrical measurement. We have heat transfer applications in engineering in a couple of weeks' time, and after that we have introduction to hazardous areas and hazardous area classification, which is actually a repeat webinar of the same webinar that we did back in May last year, if you attended that. And you can view all of our upcoming webinars on our events page on our website. And as promised, we do provide a free digital certificate of attendance for these sessions. You do need to provide your response to the form. You can access the form via the QR code on the screen, or I will provide the link in the chat box now. Just give me one moment. I've provided the link in the chat box if anyone needs the link, but the QR code is there on the screen as well. So if you're looking at it on a laptop or a desktop, you can grab your phone and scan the QR code. Otherwise, just click the link in the chat box and do the form when you can. Don't need to do it immediately, but if you can do it in the next 10 or 15 minutes, then that's great. So we will send, once you fill out the form and submit that, then we will send you a certificate of attendance in the next 24 hours. Thanks, Omar. Yep, the webinar has been recorded, so that will be sent out in the next 24 hours via email, as well as the PDF slides. Okay. Now that pretty much concludes the webinar for today. We'll hold a short Q&A session if anyone has any questions for myself or Dr. Manira. I'll skip to the last slide, so if you need to go, thanks for joining today. And our contact details are on the slide there. But if you have any questions, please put them in the chat box and we'll respond to you as quick as we can. Unfortunately, we don't have any free courses, but we provide these free webinars every week or so. So that may be an option for you, Maytham. Can mechanical engineering background apply for renewable energy course? Yep, so depending on what course you're looking to apply for, you'd need to look into the entry requirements for the specific course. And if you meet the entry requirements, then you're definitely eligible to apply. but please reach out to us if you have any questions about any of our courses. I think, Manira, there was a question for you. There's a question, does EIT have a focus group on supercritical CO2 power generation? I'm not sure if
Uh,
that
yes,
question.
Randy. So thanks for the question. There is actually in our master level and graduate certificates, they are offering the units which are involving a lot of things on renewable energy. Like we are having power generation course, and then we are having smart grid course separately. Which is actually giving you an insight about this emission sector and integration of renewable energy sector as well.
Thanks, Manira. I'm just looking through the questions. I think there's some more technical questions. So this one says, what about techno-economic evaluation of UPQC on the LV side?
Yes, so if we do the techno economic analysis of UPQC and if we compare it with other voltage regulators, then of course UPQC is a little bit expensive in terms of economics. But the thing is that actually the long-lasting results what you can get from UPQC are more good as compared to other voltage regulators. So specifically, if we are working with the systems who are having integration of renewable energy along with utility, then it's a good idea to integrate UPQC for the loads who are non-linear in nature. So for linear loads, it's okay to use any voltage regulator, but for non-linear one, UPQC is a very good solution.
Thanks, Manira. I've just resent the certificate of attendance link for anyone that is looking for that. Carl, the hydrogen course on the 24th of January, that is one of our short courses. It runs for 3 months. Unfortunately, we don't offer any free courses at the moment, but we do offer these free 1-hour webinars every week or so if you want to attend those. Yep, Cornelius, everyone will receive a copy of the PDF slides and a link to the video recording of this webinar within 24 hours via email. Thato, EIT has a range of partial scholarships. You can look at those on our website. They have different eligibility requirements and are related to different courses, but please have a look there and let us know if you have any questions. Is there an advanced course on today's course? So if you're looking for a course related to the webinar presented today, we do have a range of renewable energy courses. We have some short courses in renewable energy, but we also have units in our higher education degrees, such as our bachelor's and master's degrees, like our electrical engineering. Dipendra, we have some webinars coming up on. There's a webinar on heat transfer applications for engineering. So that could be a relevant webinar for you to watch. And then we also have hazardous areas later on. I think that's early February. Manira, there's a question here. What can be done to eliminate so that alternative energies are affordable to everyone?
So actually, nowadays, if we look, then internationally, governments are also promoting integration at their own side to facilitate the consumers. But if in order to make it affordable one, like we can have it on like rooftop solar PV system are very common in residential sectors and commercial sectors as well. So installation cost is high for these systems. I will not say that they are not, but they are high, but their long term benefits are very good. Like if you are installing these systems, then they can work for you for many, many years without having a lot of maintenance issue. So they require less maintenance. So in that sense, you can say that they are beneficial and not that much costly, because they are not giving you so much troubles for long last time.
Thanks, Munira. Obar, we have yes. So you checked the Doctor of Engineering program. I believe you will be able, you may be able to do a topic on renewable energy. Doctor of Engineering is multidisciplinary. Um, so just reach out to one of our course advisors, um, and they may be able to put you in touch with one of our academics who can advise on research areas. But I believe that is an option. Our Doctor of Engineering is quite a you know a diverse program, which allows you to choose different fields of engineering, or the ones that you are already working in. There's a lot of messages in the chat box. I really appreciate everyone's comments so far. But unfortunately, I think we've run out of time. If you do have any questions that you would like myself or Manira to respond to, please reach out to me via email. My email is on the slide. It's webinars@eit.edu.au. And our website has a lot of information about our upcoming courses. I would say our schedule page is quite helpful if you're looking at our upcoming courses, and then looking at the specific course pages, which will contain all the information about each of our courses, is quite beneficial. So thank you all very much for attending today. I hope you have a great day, and thank you again, Dr. Manira, for such a insightful presentation.
Thanks, Riley, for making all of the arrangements, and thanks everybody for attending the webinar.
Thanks, Manira.